Thank you everyone for coming. Yeah, I will talk about Podman. I'm a maintainer of Podman since about 1 year. I've been working on Podman. I've been working with on a few things. Mainly, I'm working on Windows, so support for Podman. That's my specialty. I also worked a few months ago. There was a request for actually support something that is supported on Kubernetes for Podman, and that actually made me think that before joining the team, I didn't know that Podman could actually run YAML manifest, so Kubernetes YAML manifest. So I thought that that would be an interesting talk, and that's what we are going to talk about today. So the agenda is, mainly the two main parts are those two commands, Podman kubeplay and Podman kubegenerate, that are two commands that you can find on the Podman command line, no matter if you're running it on Linux, macOS, or Windows. And then I will also like to talk at the end. I will talk about a few other features from Podman that are not well known and that are super cool in my point of view. So yeah. And but first of all, who has ever used Podman here? Okay. And who moved from Docker to Podman? Okay, cool. That's cool. We hope to convince more people to come to Podman. So this is something that, we work a lot to do things better. It's in particular for Windows and for macOS that are like where we have more weakness. But we also have some interesting features that I will talk about that Docker doesn't have. And of course, Docker has also some feature that we don't have. There is no parity between the two. Anyway, Podman has been released in 2018. There were some need from Red Hat to actually have something slightly different from Docker. There was from a strategic point of view, we wanted to do something that was requested by our customers, so more closely from what our customer wanted, and so we released Podman in 2018. Before that, the same people were actually contributing to Docker, so they continue doing the same job, but actually with a new tool that was Podman that was slightly different. It's still today mostly maintained by Red Hat. We have a lot of external contributions, so every day we have pull requests and that we review, and we are really happy about that. But companies maintaining Podman, so the real only one that's doing this job is Red Hat. But we think that this is an issue, and this is what we would like to change. That's why we have recently proposed Podman as a CNCF project, and it has been accepted recently. So there are still some things that we are doing to make it CNCF, so like appear as a CNCF sandbox project. But yeah, it's just bureaucratic things right now. So that we have made this move not because we are less involved, but because we want other companies to be involved in the project. And since the CNCF is vendor neutral, we think that with this move, there will be companies that will be happy to contribute. So big companies that will be happy to contribute to Podman and to adopt Podman. And I think that we already seen that recently with some companies that have been talking with us more than before. All right, so now I will just show a simple demo of Podman for those that are not familiar with it. And one thing is those slides are actually so those are not real slides. This is real terminal. Beyond that I will talk about this project at the end. I will provide if somebody's interested. So when I do actually here Control E, it actually runs the clean script that is here, and I will run this clean script frequently because I will run some Podman commands, and I will this clean script will actually remove all the containers, and so that I can start fresh every time. But what it actually does is just is like running from the terminal clean. That's exactly the same thing. And for example, from these slides, I can also run Podman run. This is really simple, the simplest command. So you can find it you can do that with Docker as well. Exactly the same command line, exactly the same parameters, same output, etc. And this run the HTTPD server inside the container. So I will do Control E, and actually it starts HTTPD. It exposes port 80 from within the container in the port 8080 locally. So I will be able, if I use curl, this should be more visible. And if I do Control E, then with curl I can actually do a HTTP request to the HTTP server. So I'm just running a command, so running a container and just doing a request to the service running in the container. All right. This was just for those that are not familiar with Podman. It can run is just a container manager, and that has the same command line parameters as Docker has. Now let's talk about Kubernetes pods. So the thing is, Kubernetes pods are something that developer something are not familiar with, or maybe they don't like to manage them. They prefer manage containers or compose files like Docker compose files, because it's so you may not want to set up a cluster to actually test your workloads, etc. So what I'm going to show here is simple Kubernetes pod, so the YAML file for Kubernetes, and I will show how Podman can actually manage that. So this is the example that I will use. It's a really simple pod with a couple of containers. Let me make it smaller so that it fits the page. And so there is a first container that is Redis container. You can see that the image is the default, the official Redis image from the Docker registry, the Docker Hub. And it actually also mounts a folder, a local folder here, so it will be local for Podman. But it mounts, it does a mount of a volume for persisting the Redis data. Okay. So it's simple, but it's not the most simpler pod you can have. There is also persistency that is managed. And there is a second container, there's a web container. And here you can see the image is actually localhost. So this is something that I probably need to build locally. It doesn't pull it from a registry. Okay, this is something that if you use on Kubernetes cluster will probably fail because you won't find any localhost registry. But it is useful. I will show why it's useful for us, because you can actually, when you run this pod, you can actually build the image, and you don't have to push it to a registry at all. You can just, build it on the fly and run the pod. And then, of course, there is a definition of a volume. Okay, so apart from the image here that we could change to a registry image, so the rest, so for the rest, everything works on a Kubernetes. So it's something that will work on a Kubernetes cluster. So you can test locally, and then you can then use it in production, for example. So for testing it locally, so there is this command that is called Podman kubeplay. So how does it work? So I will run this clean script that will delete the container that I ran before. And I will run this Podman kubeplay. And Podman kubeplay is actually just taking this pod YAML that we saw. So it's exactly the same file we saw before. And if I execute it, yeah, it already finished. So it started. So the output is this. Like you see that there is a line that it's a pod. So it's the ID, the identifier of a pod, and then there are a couple of containers. So it has started a couple of containers, and these are the IDs. And the two containers are the Redis container and the web app container that were defined in the pod YAML. So yeah, maybe just to make it sure that things are real or not just as like if I do podman ps here, there are actually those two containers, and actually there is a command that is podman pod ps that shows me that actually there's a pod running that created 50 seconds ago. So if I look at the images of the two containers that are running, these are exactly the same images that were in the pod YAML, so no surprise about that. And if I look if there is a volume, a podman volume, I can do podman volume ls, and I see that the volume that was defined in the YAML is actually also has been created successfully. Last thing is now I can do an HTTP request to the web application and see if it actually is working. So we'll execute curl to do that, and what the web app returns is just a counter, okay? And Redis is persisting the request. So every time I do a request, it actually increases the counter. So here you can see that, yeah, I've done that twice, and so it will continue to. So there is the requests are persisted in a volume, and that makes things actually work. So even if I stop the pod and then I restart it, so the counter will be continuously increased because the volume has not been deleted. Okay, so that's cool. Something that is cool that you cannot do with a classical Kubernetes cluster as well is doing the build actually of the Docker file that defines the image. So let me clean. Okay, so now I should have no pod running, and so if we just have a look at the pod YAML, you see that what we currently have here is this web container that has this image, localhost, etc. Okay, so what happens if we actually remove this image from locally? So what I do is here podman remove image of this localhost image, because this image is here. So if I remove it, what will happen when I try to do a podman kubeplay of the pod YAML? Let's try that. Okay, image removed, and now I will do the podman kubeplay again with this option build. And what it's doing is that instead of, since the image doesn't exist in the local registry, it's trying to build it. Okay, and it's actually building it. Let me make the screen smaller. Yeah, so you can see that the build is finished, and yeah, at the end it's small, I think, but you should see that there is again, the same output. There is a pod that has been created with a couple of containers. And how is it possible to do? How does it work? So, in my here in my folder, I have another folder that is called lopy.io_web. This actually matches the name of the container that is in my pod, and here in the lopy.io_web I have a Docker file. And so what Podman does is that if it doesn't find the image, it tries to see if there is a folder with the name of the container that is trying to run, and it looks for a Docker file or container file in that folder, and if it exists, it tries to build it. And then he tagged the image with the name that is in the pod YAML. So that's what has been done here. So that means that in your development cycle, if you change your application and you want to test the pod YAML, so you don't have to build the image, push it to a registry, and then try the pod. You can just automatically change the code, ask Podman to run like Podman kubeplay, and the Docker file will be actually built automatically, and that new version of the image will be used in your pod. So now, if we have a look at that, we can see that the image, localhost, etc., has been created 2 minutes ago. So yeah, it just the kubeplay has created the new version of the image. And if I do a Podman PS as I did before, getting only the image of the containers, and you can see that actually the two images that were used that are in the pod YAML are actually the images of the two containers that are running locally. And I can again do the Podman volume ls, and yeah, and the same thing as before. Curl will actually show me the counter now is 1 because I deleted the volume before with my clean script. So that's basically it for the Podman kubeplay. I think that you find it interesting. We have another command, similar command, that it actually does the opposite. So what it does is that you create, like you can run a container with Podman, with the simplest container like this one. And then, let's just double check that it's running. Yeah, it's up and running. And when I have that, so what I can do is that I can, with these two commands, the first command is getting the ID of the container that I just executed. And the second command is generating, is going to generate a pod YAML for that container, something that I can just pipe to kubectl, for example, and it will deploy the same workload on my Kubernetes cluster. So let's execute it. So this is the pod definition generated by Podman. And so that can be used on a Kubernetes cluster. So you can easily port your local containers to Kubernetes using Podman kube generate. Okay, so one question that you may have is, okay, we have seen pods, but what other Kubernetes objects does Podman support? It supports deployment, for example. So you can provide a deployment YAML to the Podman kubeplay command, and it will actually use it to run containers locally. The thing that it doesn't work with that's not supported, at least yet, is replicas. You cannot have, so if there are more than one replica, so if you have a couple of replicas in your deployment, it actually will only run one pod. And that's because in general, from a networking point of view, we don't have something like an ingress in Podman, so there is no load balancing that's possible to do locally. At least we haven't implemented that. There is no real request for that. So for now, so its deployment exists, but are limited by the fact that there is no load balancer. Persistent volume claims are supported. ConfigMaps, secrets, daemon set, jobs. So all those objects are supported in Podman. With always the main limitation is networking, honestly, because there are things that don't make sense locally. We haven't implemented for Podman, but that also makes the things simpler. So it's not as a Kubernetes cluster, but it's much lighter than that. So if you want something more that supports all the objects, you should use kind. But if you want something more lightweight, actually, you don't need anything else other than Podman. You can use Podman Kubeplay to test your Kubernetes object locally. As I mentioned, so this command like Podman Kubeplay was something that I wasn't aware before joining the Podman team. And there are a few other interesting things in Podman that maybe are not so popular. So this is the more obvious thing. So I think, this is kind of well known that Podman by default is rootless and daemonless. That means that you don't need root privilege to run containers when you're using Podman, and most importantly, you don't need a daemon running. So there is no need to have an API listening on a port or a socket, etc. Those are things that you can enable with Podman. For example, on Windows and on macOS, this is by default. We run Podman in a virtual machine, and it's running as a daemon. And so on Windows, there is a Windows client that will interact with the service running in the Podman machine, and then on macOS the same thing. But by default, when you install it on Linux, there is no daemon that is listening on something. So that makes the architecture simpler and easier to secure. So that is basically the main difference with Docker today. So there are things that you may want to try with Docker that don't work with Podman, and often is because of that, because there is not a daemon listening to an API. Another thing that is not well known are build farms. So build farms allow you to add some external host to your current Podman instance, and you can tell Podman, hey, if you want to build for, I don't know, like an ARM architecture, use that host. So when you do the Podman build command, it will actually offload the build of the ARM architecture or the ARM version of the image in that remote host. So you can have multiple hosts so that you can have a build farm. So we call it build farm. As actually, what is it? So multiple remote hosts that run Podman and where you can offload your builds. Another thing that is not well known, I think it's super interesting, is the ability to mount OCI images, OCI artifact images in general, as a volume in containers. So that means that if you have an Alpine container, you can actually mount there another container with some binaries, I don't know, like a JDK container, so that you will have the content of the JDK image inside your Alpine, your base Alpine container. So that means that it allows you with volumes of type image, you can compose your containers with multiple images. So it's not just from a single image, but you can compose them with multiple images, and that is popular today for AI. So you can mount AI models in containers and then run an inference server inside the container, and so that has been also recently ported to Kubernetes. So in Kubernetes you have volumes of type image, exactly for the same use case for AI models. Another interesting thing, not well known, are quadlets. Quadlets allow to define services in systemd, like systemd units that are actually going to be executed at the boot of a Linux machine to start containers. So that means that this is super interesting for use cases where you don't want the complexity of a Kubernetes cluster. You want in production to run your workload in containers, but you don't want the complexity of Kubernetes. So you can use like a Linux server, just a single node that will run your containers at the startup, and you can define it in with those quadlets. So these are like Podman commands that will add units for systemd for running containers at the start of the machine. And then the last one is Podman.sh. Podman.sh is a tool that allows you to start login session, interactive session. So when you log into your Linux box, the login is actually executed in a container. So you will run your session from within a container. So those are like not part. So at least Podman, Quadlet and Podman.sh are not core inside. These are like external project for now. Quadlet is going to be included in the Podman CLI, but I think that they are still really interesting and not well known. We got a lot of question, and we have seen usage of Quadlet by people that are not interested in Kubernetes but want to still run containers in production, and that's a great way to do that. Here are some links. So the main webpage for Podman is podman.io. We are, of course, on GitHub under the container organization. There are like 100 of repositories, and one of them is Podman, but there is also like other. So Podman is uses dependency, so uses like the storage, the container storage repository, or the image repository. So there are a lot of repository under the container organization that are used by Podman. And then if you're interested in this way to run slides, I've used PresentTerm, is a Rust command line tool to actually show a markdown file as slides in your terminal. And this the markdown of and the example of my talk are also on GitHub at this URL. To PresentTerm is really just you run PresentTerm and open it in your terminal, and that's basically it. All right, so that was it. If there is any question, I will be happy to answer.